Hey, today we're going to talk about 1.10, energy flow and the 10% rule. So take a moment to check out the Enduring Understanding, look at the learning objective, you can pause the video, review the essential knowledge, and set up your Cornell notes. So energy flow and the 10% rule is related to the trophic levels. And what we have is what is considered an energy pyramid. And this basically shows the feeding relationships within an ecosystem. And this is broken down by the trophic level. So again, down here we have the primary producers, we have the primary consumers, we have the secondary consumers. These are also the carnivores, these are the herbivores because they are feeding on the plants. Remember that? These are the carnivores, these are the tertiary consumers, also carnivores, and these are the quaternary consumers, also carnivores. This is the top predator in this aquatic ecosystem. Now, consider an NPP of 50,000 kilocalories. In other words, that means that the NPP is the amount of energy that is used or that is converted by these producers after we consider respiration. So this is all the energy that is available in the tissues of these organisms, 50,000 kilocalories. Okay, so what happens is these 50,000 kilocalories are available in the tissues. However, they're losing some as heat, so not all of it is going to be available. Each one of these trophic levels, these organisms are losing heat through metabolic processes. So only 10% of the energy at a trophic level is available for the next level above it. What does that look like? So if you had 50,000 kilocalories that was available, 45,000 of those kilocalories are given off as heat because of the metabolic activities. And only 5,000 kilocalories from the producers are available to be consumed by these primary consumers. So what that looks like, if you have 50,000 kilocalories available, the producers, as you go up in the trophic levels, you are going down, dividing it by 1/10 or taking only 10% of it. So again, in here we have 45,000 kilocalories was lost. Here we have 4,500 is lost, 450, and so on. So different ways we can show this is we can also show it with a biomass pyramid. And a biomass pyramid shows the biomass, the amount of mass for living organisms. Typically producers are going to have obviously 100% of the biomass. Primary consumers will have about 10%, and you're going to have 10% available. One of the reasons we don't have quaternary or a fifth, like a fifth consumer, is because there's not enough energy available. As you keep going up, the amount of organisms that would need to be present are so, it just doesn't work out mathematically speaking. So you won't have more than a quaternary consumer. Also, when you show the biomass pyramid in an aquatic ecosystem, it's going to look different. Typically, it will be inverted. The producers may have a smaller biomass, and the primary consumers may have a larger biomass because of a lot of the producers are going to be photosynthetic algae, and you will have a lot of other organisms consuming those. So the biomass pyramid is going to look slightly different in an aquatic ecosystem. But in a terrestrial ecosystem, it's going to look like this. Relative sizes. This is 10% of this one. So if you measured this out, this would equal 100. In fact, it does because I drew it up myself. This is 10, this would be 1, and this is 0.1. So that 90% that's used up for metabolic activities is for things like cellular respiration. So cells can grow, so they can develop, and so they can move for transportation, locomotion. Also reproduction, any sort of biological process that is happening in these organisms is using up 90% of that energy. What I would like you to do is practice writing an FRQ response. So I want you to explain why a relatively large freshwater lake could only support a small number of cormorants. look at this feeding relationship that we have here. Hope that this video was informative. I thank you very much for your attention, and I will see you soon.